Hi, this is Marwan, and today we will be talking about quadratic functions. We are going to be discussing the vertex form of quadratic functions. We have multiple examples where we're going to see how to tell the transformation of a quadratic function, how to graph it, how to tell the key features we have, and how to find the equation of a quadratic function using the vertex form. The concept we are going to discuss today is representations of quadratic functions. A function is a quadratic function if its equation can be written in the form of f of x equal ax squared plus bx plus c. Now, why ax squared plus bx plus c? Because here the highest degree of any of the terms of the equation we have is 2. So because the highest term is 2, then this is a quadratic function. Has degree of 2, this is a quadratic function. With a does not equal to 0. What do we mean by that? If a here is equals to 0, when we multiply x squared by 0, we will not have this term. So this is why a should never be equal to 0. So if we have an equation of a function, and that equation includes ax squared, then this is a quadratic function. Having bx and c is an addition, okay? But a is the only thing that should not be equal to 0. If b is equal to 0 or c is equal to 0, it's okay. All quadratic functions are transformation of the parent function defined by f of x equal x squared. Now this is called the parent function because this is the simplest form of quadratic functions. When you look at it, it will be represented by a parabola, the one like we have here, and it has a vertex. This is called the vertex, which is h and k, and in this case it's at the origin. The value of h and the value of k are both equal to 0. H and k represent the vertex in any quadratic function. The graph of a quadratic function is called a parabola. So this shape here, we call it a parabola. Any quadratic function is usually represented by a parabola. This parabola could be looking upwards, downwards, it could be translated or transformed in any way, but it's always a parabola. The vertex form of a quadratic function is, now this is the vertex form. This is what we'll be working with in this lesson. F of x equal a x minus h all squared plus k. H and k, as we said, represent the vertex. Is the vertex of the parabola. Vertex form is useful because it highlights the vertex of the graph of the quadratic function. So once we see a function written in this form, it's easy for us to find the vertex. We have our first example here. It says describe the transformation of the parent function f of x equal x squared to the function you have here, then graph the transformed function. Okay, so the first thing we need to do is to describe the transformation. How do we describe the transformation? Remember, we discussed before that we can, from the values we have, -2, 1, and 1, describe the transformation. First of all, I know that a is equal -2. When a is equal -2, whenever we have a negative sign, we said that that negative sign will show reflection. So this here will show me reflection. And because we have 2, then we know there is a vertical stretch. How do we know? We said that if the absolute value of a is greater than 1, this shows vertical stretch. We discussed that before. And if the absolute value of a is between 0 and 1, then this shows a vertical compression. Okay, so let's describe the transformation together. We're going to say the graph of the function has what? First of all, what happened first? As we said, negative sign, then reflected over the x-axis. This is the first thing we know. We have the value of a equal -2, then the absolute value is equal to 2, which is greater than 1. Then what else has happened? The graph is also stretched vertically. We can say by a scale factor of 2. So this represents the vertical stretch. So whatever number we have here, this is the scale factor. What else happened? Now these two numbers, the one inside the parentheses and the one outside, which is the values of h and k if we remember, these two values represent the horizontal and vertical shift. Now h represents the horizontal shift. Like remember, it's h and it's horizontal. So this has been shifted or translated how many units? 1 unit. This is the value of h. Okay, to the right or to the left. Remember that whatever is inside the parentheses, we take it with the opposite sign. So the value of h is -1, then we have moved to the left. Okay, so 1 unit left. This is the first thing. The value of k, which is outside, represents the vertical shift or the vertical translation. But this is always in the same sign. So if it's positive, it means it moved up. So I'm going to write here and 1 unit up. So how many types of transformation we had in this function? It was reflected, it was vertically stretched, and it was shifted in 2 directions or translated in 2 directions, vertically and horizontally. So we did the first part, which is describe the transformation. The second part then graph that transformed function. Now how do we graph the transformed function? Remember, we have the vertex form, which is y equal ax minus h squared plus k. Using this, we can find the vertex. The vertex is h and k, as we said. So the vertex here is h and k. The value of h, because it's negative in the original function, in the original vertex form, then we take the opposite sign. So the value of h is -1. The value of k is 1, so we found the vertex. What else can we find? We can find something that we call the axis of symmetry. Now, the axis of symmetry, any parabola has an axis of symmetry. The value of this axis of symmetry, its equation is x equal to h. So it's x equal to -1 in this case. How are we going to use this? Let's look together. We said that the vertex is -1 and 1. So the first thing I'm going to do, I'm going to graph the vertex at -1 and 1. So the value of x is -1, the value of y is 1. So this is my vertex. Okay? I have axis of symmetry, x equal to -1, or passes through the vertex, as we know. So I'm going to draw an axis of symmetry here. Now, my drawing is never going to be accurate because it's not easy to draw the way we're working here. So I have the vertex, h and k, and I have the axis of symmetry. I'm going to use those for graphing, and because we have a stretch, then we are going to make a table. Always, we're going to make a table, and in this table, we're going to use only 3 values, then we're going to do something different. The first value I'm going to use is the value of the vertex, which is -1 and 1. I already know it. Then I'm going to choose 2 other values to the right of the axis of symmetry, then reflect them. So now I had x equal -1. I'll take to its right x equal to 0, and to its right x equal to 1. How do we find the values of y? We are going to substitute. So I'm going to substitute in the equation I have f of 0, which means instead of x, I'm going to substitute for x equals 0. It's going to be -2. Instead of x, I'm going to put 0 again, plus 1 squared plus 1. Now, -2, 0 plus 1 is 1, 1 squared is 1, so this is -2 times 1 plus 1, which is equal to -1. So I know that when x is equal to 0, y is going to be equal to -1. Then I'm going to substitute for x equal 1, so f of 1 here is -2 times 1 plus 1 squared plus 1. 1 plus 1 is 2, 2 squared is 4, 4 multiplied by -2 is -8, plus 1 equal to -7, so my point here is -7. I'm going to plot these points on the graph. I have -1 and 1, then 0 and -1, this is my second point. Then my last point is 1 and -7. Unfortunately, I don't have -7 here, so I'm going to draw it like that. Once I drew these 2 points, I will have to reflect them. Reflect them on the axis of symmetry. So here, this is 1 unit away from the axis of symmetry. I'm going to reflect it on the other side, 1 unit away. This is 2 units away from the axis of symmetry, so to the other side it's going to be 2 units away. Then you're going to connect your parabola. Actually, it's very hard for me to connect it here, but you will have better chances connecting it on your... it should never be a straight line, it's a curve. So I can't really... So even the vertex, it has to be a curve. Now, this is not easy at all. But once you connect your parabola, the points you have, then you have the curve you asked for. Now, looking at this parabola, we can see that our description was correct. This parabola is reflected. It opens downwards, as we can see. It is shifted. If the parent function was at 0, 0, it is shifted 1 unit to the left and 1 unit up, as we said. And it's stretched, because if we see the parent function, we'll find that its graph is a little wider. Example. Now, this example here is quite different. This is the example that will help us find the key features of any function. It says here, identify the vertex, axis of symmetry, maximum or minimum, domain and range of the function. So I have a function here. First thing I need to find is the vertex. Remember, the vertex is h and k. H here is equal to -2. As we said, we take the opposite sign. K is equal to -1. So the vertex is -2 and -1. So this is done. Axis of symmetry. How do we find that? Axis of symmetry is always x equal to h. Always. This is an equation of a line. X equal to h. So h in this case is equal to -2. So the axis of symmetry is x equal to -2. So on the graph, like we did in the previous slide, when we drew the axis of symmetry passing through the vertex, this is what we're going to do. The equation of the line is going to be x equal to the value of h. So this is what you're going to write. So we found the vertex, the axis of symmetry. I want you, when you solve a question in a test or quiz, make sure that you tick everything you solve. Now, if this is a maximum or a minimum, now the maximum or the minimum is actually the vertex of the parabola. How do I know if it's a maximum or a minimum? If the value of a is greater than 0, if the value of a is greater than 0, so the value of a here is positive, then the parabola is looking upwards, right? So the vertex is a minimum. Why do we call it a minimum? This is the minimum point of the parabola. If the value of a is less than 0, so if it's negative, like in the previous example, then the parabola will be opening downwards like that, and its vertex is going to be the highest point when it comes to the values of y, so we call it in this case a maximum. Okay, so for this case of the function, because the value of a, which is equal to 1/3, is greater than 0, it's positive, then I know that this parabola has a minimum, and this minimum is the value of y, or the value of k, okay, which is y equal to -1. This is the minimum, okay? This is the minimum. The minimum value is y equal to -1, or we can write it as the vertex, which is much easier. So the minimum point is the vertex, or the maximum point is always the value at which you write the value of y, which is equal to -1 in this case, okay? So always the minimum or the maximum is the lowest point or the highest point of the parabola, depending on which direction does the parabola open. Okay, so here we did find the maximum or the minimum. Of course, you will find only one of them. Each parabola has either a maximum or a minimum, not both. Now the domain To find the domain of any function, all polynomial functions, including the quadratic functions, have a domain from -infinity to infinity. So the domain is all real numbers. You can write it as -infinity to infinity, or write it as all real numbers. Both are correct. Okay? So the domain is from -infinity to infinity, regardless what kind of transformation is there. -infinity to infinity is never affected by a translation or stretching or shrinking or anything. So if the domain is -infinity to infinity, it's always -infinity to infinity. It does not change. For quadratic functions, regardless what are the numbers we have, what type of transformation has been done, the domain is always -infinity to infinity for this type of functions. The range, however, does depend on the numbers we have. Now, this parabola, if we sketch it, we don't have to sketch it every time, but I just want you to imagine. We just said that its vertex is at -2 and -1, right? So the vertex is here. And we know that A is positive, so we know that this parabola is looking upwards like that, and its axis of symmetry goes here. I'm sorry, it's not that clear, it's not easy to write. But this is how my parabola looks. Now the range is, as we discussed before, all the possible values of y. So it starts from here going upwards, right? Because it opens upwards. Now what we have here is the lowest value, which is the value of k. So always my range starts from k, right? If the parabola opens upwards, then it's from k until infinity. If it opens downwards, it's from -infinity until k. Okay? So in this case, the range is going to be all real numbers that are equal to or greater than k, because the parabola opens upwards. So I'm going to write it like that. It starts from -1, right? And this bracket is because -1 is one of the values included in my graph, until infinity. Or I can write it as the range is equal to all real numbers that are greater than k. So the values of y are greater than or equal to k. So the values of y are greater than or equal to -1. Okay, this is my range. If the parabola opened downwards, we start from -infinity until we reach that point. So this was our second example. Our last example for the lesson is how we can write an equation of a parabola in vertex form if I have 2 points. So I have the vertex and I have a point and want to find the equation. Okay, so we don't have the equation, but we do have a vertex and we do have a point which the parabola passes through. Now, if I know that the vertex is 1 and 2, so I know the value of h and the value of k. The standard form we know, the vertex form we know for a quadratic function is y equals, and I have here a x minus h squared plus k. This is the vertex form. Now let's substitute for the values of h and k. So I have y equal a multiplied by x minus 1. I just substitute. I leave the signs as they are. Squared plus 2. So what did we do here? We just substituted. My problem is how to find the value of a. Now I do have a point. This point represents one of the points on the graph, and that point has an x coordinate and a y coordinate. So I can actually substitute for x and y by these values after I found this form. Then, using that, I will only have one variable in the equation, which is the value of a, and I can find it. So let's substitute. So we did the step 1, which was just substituting for h and k. Step 2 we're going to do is we're going to substitute for x and y. So y is -5 equal to a multiplied by x, x here is 2, minus 1 all squared plus 2. Let's simplify. So we have -5 equal to 2 minus 1 is 1, and 1 squared is still 1, so a plus 2. Now let's solve by subtracting 2 from both sides. Then you're going to have a equal -5 minus 2 and A will be equal to -7. Now, I have found the value of A, we have found the values of H and K. Now we can write our equation. So the equation, our objective is to write the equation. So how do I write the equation? Again, using the vertex form, I have y, we don't substitute for y, equal -7, open parenthesis, we don't substitute for x, minus h, which is 1, squared plus k, which is 2, and this is the equation we require to find. So whenever we have 2 points, one of them is the vertex, substitute for the vertex, then substitute for x and y using the point, then simplify to find the value of A, then plug in A, H, and K in the vertex form of a parabola, and then you have an equation for that problem. I hope you found this useful, and thank you all so much for watching.